This question is from the Hong Kong International Mathematical Olympiad 2022. Here's the question. How many pairs of positive integers m and n are there such that m squared times n equals 20 raised to the power of 20? Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. So how many pairs of positive integers? So we know m and n are positive integers such that m squared times n equals 20 raised to the power of 20. Now in this video, I will show you 2 different methods to answer this question. So the first one is by using algebra approach, and the second one is by using the tau function. So the tau function is a way or a function to find the number of positive divisor of any given number n. So now let's focus on the first method, algebra approach. Now, we have here m squared times n equals 20 raised to the power of 20. So what we're going to do here is to factor out this 20. Let's get this prime factor as 2 squared times 5. Now, using some laws of exponent, the right-hand side of our equation can be written as 2 raised to the power of 40 times 5 raised to the power of 20. Now, let's focus on this result. And now, since the right-hand side is in the form of 2 raised to the power of 40 times 5 raised to the power of 20, so we can say that we can rewrite m in the form of 2 to the some power times 5 raised to the some power. And also, this n, we can rewrite same thing as 2 raised to some power times 5 raised to some power. So we will use this substitution for m and n. And if we do that, we get something like 2 raised to the power of a times 5 raised to the power of b squared, which is our m, times 2 raised to the power of c times 5 raised to the power of d, or simply our n. And now, applying some laws of exponent in this expression, we have something like 2 raised to the power of 2a times 5 raised to the power of 2b. Now, since multiplication is commutative, we can rewrite this left-hand side as follows. And now, since we have now the same base, 2 raised to the power of 2a times 2 raised to the power of c, we can simplify this as 2 raised to the power of 2a plus c, and we have here 5 raised to the power of 2b plus d. Now, let's focus on this result. Now, comparing the left side and the right-hand side, we can say that the powers of 2 must be equal, or 2a plus c simply equal to 40. And 2b plus d simply equal to 20. And now from here, since a and b, or n and m, are both positive integers, so the only possible value of a must be 0 to 20. If a is 0, c is 40, a can be 0 because 2 raised to the power of 0 simply equal to 1, and still a positive integer, alright? So a can be 0 to 20. And on the second equation, by the way, the value of c depends to the value of a. If a is 0, c is 40. If a is 1, then c must be equal to 38, and so on and so forth. And on this equation, the possible values of b simply equal to 0 to 10. Therefore, the number of ways to choose a and b, the number of ways to choose a is 21 ways from 0 to 20, and the number of ways to get the value of b is 11 ways from 0 to 10, and that is the number of ways to find a and b, and that is the value of m. And the value of n depends on the value of m. So the total number of ways, or the number of pairs of n and m, simply equal to the product of 21 and 11, which is 231. So how many pairs of positive integers m and n are there such that m squared times n equals 20 raised to the power of 20, and our answer is 231. pairs. So using algebra approach, we get 231 as our final answer. And now, how about the tau function? This is a bit shorter than the first method. So let's do that. Again, tau function is a function to get the number of positive divisors of n. So we know a n or any natural number, we can factor this out using some prime factors. So n can be equivalent to p sub 1 raised to some power. This is a prime number raised to some power times the second prime number raised to some power times the third prime factor raised to some power, and so on and so forth. Now, the tau function simply equal to a plus 1, the exponent of the first prime, times b plus 1 times c plus 1, and so on and so forth. This is the number of positive divisors of n. So we will apply this to this question. So to do that, let's divide both sides by m squared. Now, 20 is 2 times 10. So we can rewrite the right-hand side as 20 raised to the power of 10 over m raised to the power of 2. Now, since n is a positive integer, this expression, 20 raised to the power of 10 over m, must be an integer. And since this expression must be an integer, this m must be a positive divisor of 20 raised to the power of 10. That's how tau function comes into play, because tau function is a function to find the number of positive divisor of n. So what we're going to do here is to find the total number of positive divisors of 20 raised to the power of 10. And to do that, let's factor out 20 by its prime factor. So this is just 2 squared times 5. Now, using some loss of exponent, we can rewrite this as 2 raised to the power of 20 times 5 raised to the power of 10. Now, we can now use the tau function. We can now apply this to our number 2 raised to the power of 20 times 5 raised to the power of 10. So the tau of 2 raised to the power of 20 times 5 raised to the power of 10, or simply the possible value of m, simply equal to 20 plus 1 times 10 plus 1. And 20 plus 1 is 21, 10 plus 1 is 11, so I have 21 times 11, or simply equal to 231. So this is the number of possible values of m, and also it corresponds to the number of possible values of n. Therefore, how many pairs? And our answer is 231 pairs. And this is our answer to this question. Therefore, given this question, how many pairs of positive integers m and n are there such that m squared times n equals 20 raised to the power of 20? Then using two methods, we get the same result as 231 pairs. And as always, we are done.